we're looking at kind of what are the human patterns of behavior through the cell phone data. So this is kind of a still, it's actually a whole video, but this is called the signature of humanity. We're actually looking at the data and the patterns over time. So what you're seeing is like the daily cycle, separated by different continents, and you can actually see kind of the intensity of activity. So then when you actually look at that, you can actually begin to see population dynamics. So we have a project that looked at the United States. Can you draw a map of the United States based on our connectivity socially through telephone, SMS, all that, versus kind of geography or a war that happened 200 years ago. So thinking about it in kind of a political sense, the UK has approached us, to help them think about their process of I don't know what it is, but like redistricting, drawing new constituencies based on kind of our findings of what are the social boundaries. So are you actually cutting a constituency in half because of the connections between people? So talking about that, kind of on the planning side, but kind of on the other side, which is just interesting, is just see kind of how we talk to each other. So the colors actually represent different types of data. I'm not sure which is which, but one is phone, and I think at the bottom is like internet or data. So I'm not sure what it is, but you can actually see the patterns of human use and the differences between Asia. So Asia has kind of a different kind of color configuration than the United States, and they use it differently. A stronger white, which I think is actually maybe voice. I'm not sure, SMS something. But then that's different from South America. We also did from other continents as well. Going back to the idea of responsive environments, instead of taking a cue from technology, can you take a cue from biology? So one of the theses is, that our researchers have is that crickets respond to sunlight, in a certain way. So could you actually create a dynamic shading surface using crickets who move within this little canopy? So this was a test of how to feed them. And we've, inadvertently killed thousands of crickets in the test. Because we learned a lot about
Hey, you can't make an omelet,
I know. It's just quite sad. So we've learned, going from something this shallow to something thicker, so we're still developing it. And it's showing some promise. We're finding some things. So one thing we did learn recently, we did a little demo for parking day. We did it right in front. Was that crickets are territorial and they become very aggressive when they're in close confines
with other crickets.
Right. So the mass genocide was that they were actually all killing each other because they didn't have that much space. So when we moved to a three-dimensional structure, so three-dimensional, even if clear,
you're still creating the same amount of shade.
Exactly.
They're just not as close.
In 2 dimensions, you're creating the shade. But in 3 dimensions, you're giving the crickets a little more space. So that was kind of a promising discovery. So we used to have a box, but I think I asked them to toss some of our prototypes away because you can get crickets in, but you can't easily get them out. And when they're dead, they smell. So I've
Fair
asked
enough.
them to get rid of some of our prototypes because they were.
Are these like chirping crickets? What do you do about the noise? Is that just like a nice ambiance, or?
So yes, usually. The problem is that sometimes we have. We have presentations and there's an awkward silence or something.
And then crickets.
So we have toast. So whenever someone leaves the lab, we have a toast, and it's always awkward because you've done the toast, then what? Before the conversation picks up. So once we're standing there, there are really crickets in the background.
That's too good. That's too good.
More awkward. So. The problem with heating right now is that we don't heat people, we heat the air, which heats you. Right. So all the molecules that don't touch you is wasted energy. So our question is, can you use new technology to actually heat you as a person, to create for you a bubble of heat that follows you around as you move through? So this was version 1.
Awesome.
So this was, so the project is called Local Warming.
That's good. You guys are good at that stuff.
We have a team of people who just come up with crazy names. So this was
we should speak to them.
Yeah. So this was
yeah, we were looking for a name.
Prototype version 1. Yeah, after what is it? Smart, create, Local Warming. We can come up with names. But this was put in front of MIT over the door. So as you walked in, basically on this rug was out there too. You would put your feet down, and a camera would actually lock onto you. And as you walked around, this would actually follow you, providing you with a bubble of heat.
Pretty cool.
The problem is with this, if you have two people and one person standing in front of you, you don't get the bubble of heat. So our kind of idea of the Eye of Sauron type of beaming energy, cool, but didn't quite work. So with the question about the hexagonal thing, this was kind of iteration 2, where we moved from a single point of energy to an emissive surface. So this is kind of another test. So this would actually be at the architectural scale, and each of these hexagons would actually be this big, and three-dimensional, where you could actually create kind of a 360 kind of surface of heat. So no matter where you move, we can target you with a little bit of infrared heat. So if this was hooked up, this is basically hooked up to the Connect, where as you moved your hand, the specific bulbs would turn on. So this is kind of version, 2 light or 2 alpha, whatever. So we're hoping to actually move to the next scale come December, where we actually do this at an architectural scale and actually 3-dimensional, so that we could actually have all that technology working and actually following people around, giving you kind of that little bit of heat.
Very cool.
So, and we're actually testing. So one side is the design, development side, and then the other side is the research. So we're actually trying to see, with this system, we're accounting for costs and seeing at what point does this make more sense than our conventional heating systems.
Right, that's what
Is it
purely economically?
Yeah, economically and energy consumption. So does it make sense to maybe use natural gas systems, which we use around campus for sure, to heat up a building to a certain degree and then let this take over for the rest? Or what's the temperature differential? How do you actually measure for comfort? So we're actually then moving into kind of the science side and actually testing to see how successful this is as a concept. Because it would suck if we did this and then we end up using significantly more energy than we're doing. So we actually have a team thinking about how this can actually move to market later on down the road. So there's a team kind of students that we're working with who's actually considering that as part of it. The project in Singapore is trying to look at, with all this data that we produce in the city, how do we create tool sets for people to actually make it accessible? One of our arguments is that data is powerful, but it's scary right now because it's not, the processes are not transparent. The NSA stuff using metadata, scary, but it's also the same process that we use to help plan cities. We look at the same data. That a lot of new discoveries in science and medicine are also coming from that same data. So when we actually kind of build awareness, we think we can take away at least some of the creepiness and actually move to a better discussion about, not just about whether people should be doing, this analysis, but like how should we actually respect that with regards to policy and ethics? What is that line? Which is a much more intriguing, much more thoughtful question. So with this, we're collecting data from all across the island. And here we're looking at bus data. So through a series of interactive visualizations, which at this phase was a prototype, could you actually create something that's intuitive for people to see the dynamics of their bus ride in real time? So you can click on any stop and see kind of the greater connections. So is everyone getting off at one stop and getting off at another stop? Or what are these connections? You could also kind of select through and see if you're going from point A and this point B, what's the best route, keeping in mind how crowded the bus is, whether it's on time or not. So it's not just the next bus is coming, it's actually now talking about things that also impact the quality of your ride. Maybe it's worth it to wait 3 minutes for the following bus because it's empty. So now we're actually creating tools for people to do that. And then on the planning side, LTA, the Land Transit Authority, who runs all kind of ground transportation in Singapore, when they saw this, they were really interested because, especially if you're clicking at this stop, Vivo City, it's near one of their bus depots. And they're like, well, if everyone's getting on here and off of here, why don't we have an express bus that will come in and actually relieve that? If they're getting the data in real time, why not actually change the way they provide service? Especially if it's so close to a bus depot.
Right.
So now they're actually, now we're thinking about how these tools also kind of move into the hands of kind of the planners, the decision makers, which is, in Singapore, you only have to convince one person.
Right.